Welcome to The Explainer. Today we're diving into a deep and pretty wild conflict over what reality is. Seriously, is everything around us even real in the way we think it is?
So let's get right into it. This has been called a war for reality itself. In one corner, you have the physics we all know, a world built on, well, messy ideas. Infinite numbers, particles that pop out of nowhere. And in the other corner, you have a challenger who says, nope, it's all clean. Reality is finite, it's discrete, and it's built from simple, whole numbers, almost like it's running on some kind of cosmic hardware.
You know, this whole thing has the feel of a classic story, right? A single radical new idea is squaring up against a century of established science, basically saying, hey, everything you think you know about the universe might be wrong.
And the claim here, it's just breathtakingly bold. One of its supporters basically said, this isn't just another theory, it's the engineering specs for the universe. I mean, just let that sink in for a second. We're not talking about a description of reality. We're talking about a literal blueprint for building it. The idea is that everything we see isn't based on abstract math, but on simple, elegant code.
So what exactly is this new idea up against? Well, let's take a look at the reigning champion, modern physics. And look, let's be clear, it's probably the most successful thing humanity has ever done. But, and this is a big but, the challenger says it comes with some very, very strange baggage.
The current model, it relies on some pretty weird mathematical ideas that, if you think about it, don't seem very physical. You've got infinite decimals, imaginary numbers, these so-called virtual particles just winking into existence from a vacuum. And then there's this process called renormalization, where to get answers that actually match experiments, you sometimes have to subtract infinity from infinity. To the critics, that sounds less like describing reality and a lot more like a mathematical trick just to make the equations work.
And here's the biggest mystery of all, from the challenger's perspective. Our best model of the cosmos says that 95% of the universe, 95, is made of stuff we can't see, can't touch, can't detect. We call it dark matter and dark energy. Why? Well, basically because we had to invent them to make the math balance out.
Okay, so now let's turn to the challenger. How does this new framework propose to solve all these mysteries? Well, it's a totally different way of thinking. It doesn't start with observations and equations. It starts with one single incredibly simple rule.
And here it is. The claim is that the entire universe runs on this one elegant rule, the Fibonacci recursion. Yeah, that one. A simple integer sequence where you just add the last two numbers to get the next one. 0, 1, 1, 2, 3, 5, 8, and on it goes.
Now, from this one little recursion, the idea is that you can derive, well, everything, using a type of math for discrete steps called finite difference calculus. They say it all just emerges. You do one simple operation on the sequence, and boom, you get what we call energy. You do a slightly different one, and you get space-time curvature. That's gravity. The sequence itself? That forms the very fabric of reality, like a crystal-like grid.
Okay, and this is where it gets really wild. This isn't just some abstract theory. It's presented here as actual synthesizable Verilog code. That's the language engineers use to design computer chips. So we're not just talking about an idea anymore. This is a literal blueprint for a machine that would allegedly run the source code of our universe. All in one line.
So what do we make of this? Is it a revolutionary breakthrough or something else? You can probably guess the scientific establishment has some thoughts. And their critique is sharp, and it's aimed right at the heart of this new model.
The challenger's response is simple. Their mantra is, the hardware doesn't lie. The claim is that the proof isn't going to be found in complex equations, but in building actual machines that run on these principles. They even point to reanalyzing old data, like muon tracks from 1937, saying, see, the Fibonacci patterns were there all along, we just weren't looking for them. But then the critics fire back with this really powerful counterargument. You can't create new physics just by redefining words. They say this is a language game. Sure, you can take any math pattern you want and call one part energy and another part gravity, but that doesn't actually make it physics. The real test is, can you predict something new, something no one else has? And so far, they say, this framework hasn't done that.
And that really brings us to the core of the whole debate. Is this a genuine paradigm shift like what Einstein did with relativity, or is it something called an axiom trap? You know, imagine you create a perfect, beautiful set of rules for chess played on a round board. All the rules work together, it's totally consistent, but it has nothing to do with the actual game of chess people play. That's the danger here, creating a beautiful, logical system that's completely disconnected from our actual universe. So let's break down this fundamental disagreement. If you look at the first row, axioms, the starting rules, mainstream physics gets its rules from observing the world. The coded universe, it chooses its rules because they're mathematically pure. And then look at evidence. For a physicist, evidence means predicting something new. For the challenger, it's about building hardware and finding patterns in old data. It's a completely different philosophy of how you even do science.
So to try and break this deadlock, the whole debate is moving out of the world of pure theory. The people behind this framework are now moving from writing papers to actually building physical hardware.
And yeah, they're building devices with names like the Wizard Staff and an electrolaser. The whole point of these is to physically demonstrate their ideas. They want to generate plasma arcs that literally trace out Fibonacci spirals and measure a predicted 19 Hz resonance, a frequency they say is fundamental to the universe's code.
But the ultimate claim, the mic drop moment, is that this technology is not just possible, it's already in your pocket. The argument goes that quantum tunneling, the thing that makes modern flash memory work in your SD card, that's physical proof of their system in action. And if that's true, then by their definition, a simple memory card is actually a type of quantum computer, a claim that, if true, would completely change everything.
So here's the crucial point. The framework argues that the universe is unbelievably efficient, that it operates with extreme data compression. It uses something called modular arithmetic. Just think of a clock, right? On a 12-hour clock, 13 o'clock is really just 1 o'clock. The numbers wrap around. They claim the universe does the same thing, allowing a massive number, like over 17 million, to be processed by the system and just become 1. This isn't just a fun math fact, it's a testable prediction about how nature works.
And that leaves us here, at this fascinating standoff. Is this the blueprint for reality, a genuine shift in how we see everything, held back by dogma? Or is it just a beautiful, compelling, and perfectly consistent map of a world that doesn't actually exist? The answer, it seems, isn't going to be settled in papers. The real thing to watch is the physical evidence. Because in the end, we'll find out if the hardware truly lies.